Right, hello and welcome back to another video. Today we're going to be carrying on with our Niagara series, looking at mesh particles. So last time we looked at flipbooks, how we can use texture as animation. Now we're going to be looking at a different type of renderer in Niagara, and we're going to be looking at using meshes directly in the particle system, and some common examples of how we might do that. So let's get started. So here in the meshes, I've imported a few meshes already. We looked at leaves last week for the flipbook, or last time for the flipbook. We're going to do the same again here, and we're just going to use a 3D mesh. So really simple way of getting a bit more geometry, maybe a bit more realism than just a flipbook, but different costs involved with it as well. So heading it back over to Niagara, I'm just going to actually copy the system from last time and see how this works. I've had some issues with copying things before, but let's hopefully this works. So we want basically the same kind of settings and everything. So what we're going to be doing here, you can see here we have our sprite renderer, and this is a 2D plane pointing towards the camera by default. And you can see we get the little squares, and we're playing that material on this. So actually what we're going to do is just disable this, or in fact just delete it entirely, and we're going to add a new renderer, and it's going to be the mesh renderer here. Now one of the things that that Niagara does that Cascade didn't do, if I'd actually just undo that and get my sprite back, come on, is it allows you to have multiple renderers per simulation. So here we're calculating all this position, we're using forces and what have you up here, but if I then add a mesh renderer as well, we can have two sets of thing, in this case one leaf mesh and one leaf flipbook sprite, and you can see, I mean the scale's all wrong, but you can see that each one of these now has both things in the same location. Really nicely for doing things like lights and ribbons, this kind of stuff. We'll maybe get onto those a bit later on, but it means we can do one simulation and drive multiple things with it, which is pretty useful. So yes, in this case we're not going to be using a sprite renderer, we're just going to be using the mesh renderer, and you saw here I just added the mesh into here, and then we have various settings. Now first thing that's going to be noticeable about these is the sizes. They're all huge. So before we were scaling our size, we have an initialized particle, we have a size here, but we're not using sprites anymore. So all these sprite attributes are actually not doing what we want. So I might just reset these all back to default and turn them off, because we're not actually using sprites at all, we're using meshes. So in this case we've got a mesh scale value. So these are then all being controlled by this. So if I put this down to 0.5, you can see we've halved in size. And so we want to do a random value in here for our initial size. And we're probably going to do a single uniform scale. So again, the way Niagara works, we can do a vector from float, and then we'll do a random range float. And so now we're going to have, let's say, 0.1 and 0.5, something like that. And we can see our leaves are now going to be uniformly scaled because we're randomizing a single value and extrapolating that up to a vector. Similarly, our rotation. So here we had initialized spawn, we had, I've hidden it now, but sprite rotation. Well, we need to have mesh rotation now, and there isn't a setting in here for mesh rotation. But if we open up into here, there's a module, initial mesh orientation. So we create this, and in this case it's giving us a direction vector to point towards, so an orientation vector. In this case it's pointing in X, so all our meshes are pointing in X. If I set this to Y, you can see they're now all rotated differently. Z similarly, and so we need to control our 3D object with 3 sets of orientation, or in this case an orientation vector. Instead, there is a rotation option. So in this case they're now 0, and we can rotate around the x-axis. This is probably in degrees. Yeah. and we can do it this way as well. So a random number within for a rotation, or just a random orientation vector. And I'm just going to do a random vector, and that should just give me all my objects having a different orientation. So a couple of things that need to be different for meshes. Could clean these up. We're not using the these material parameter things anymore. Just go through. We're not using a sub-UV animation anymore. We're not using a sprite rotation rate. If we do want these to rotate, we want our mesh rotation. There is just a mesh rotation force, so we could apply this as a force. We fix this to get it in the right place, and we could add some spin. That's being added repeatedly every frame, so you can see it's starting to accelerate. So maybe we want to have an initial force, and then it'll just happen once, and now we've got an initial spin value to those meshes. So just a slightly different way of accessing and controlling meshes. We have to think about them. They're 3D objects. They're going to have multiple things for orientation and rotation, rather than a sprite, which is just a 2D thing. Looking pretty cool. So a couple of other places where you might use meshes. There are so many ways of doing this. Once we've got into using meshes and combining materials and combining particles, it all combines really sort of infinitely to create whatever you want, whatever you need. But there's a couple more sort of examples where we can use meshes. Let me just create a quick system for this. On S leaf mesh, so I can have it in the world and see what it looks like. And then we have a 3D falling meshes, and you see I didn't change anything to do with the forces and acceleration and velocity. That's all the same, whether it's being the leaf sprite flipbooks or whether the leaf mesh. As I say, the simulation's the same in both cases. We've just put a different renderer on it. So a couple of other things where we might use meshes where it can work quite nicely. One thing we can do is what I would call a mesh flipbook. And so if I open up here, I'm not going to go into all of the details of this, but we have an animation. So this is a simple mesh, and what I've done is I've just modeled every single sort of possible position that the wing could be in as separate pieces of mesh. And then we're just using the material to scroll through that with a simple mask, and this is then kind of like changing the opacity. So only one of our meshes or one of our animation frames is ever visible at one time, but we're able to get 3D meshes and get animations. So one thing we can't do with Niagara meshes, or Cascade for that matter, we can't use skeletal meshes, we can't import animated meshes, so we have to do the animations in a different way. So in this case we've done it by manually putting in every flipbook, every frame, so similar to the leaf flipbook, but now we get sort of 3D geometry and movement to that, and we can load that into Niagara. And then the other type of mesh we might want to use, complex geometry, so complex shape. Here this is simple spiral. Getting an object to follow a simple spiral could be quite tricky, but we can model a simple spiral very easily. And then I've just made a quick material spiral, which is just scrolling along that mesh. And you can see how by creating a mesh that has these sort of shapes, let's make that double-sided, make it a bit easier to see. And again, very simple material here. I'm just using the generated band function to create a thin stripe and just panning it up and moving it up. And if we see here, we're now getting that complex shape out of the mesh because we're controlling and only having some visibility some of the time. So let's just try using this spiral, create a quick effect for it, and we'll see a couple of problems we'll run into, and then another little feature that's quite useful to know about. And just check I didn't do it last time. It's been a few weeks. No, it hasn't. It's fine. Cool. Awesome. So if I go into my Niagara set, I'm going to create a brand new effects new effect type, any spiral mesh. That's not the right thing, not effect type. Effects, new emitter, here we go. New from a template, I'm going to do a blank empty one, NE spiral mesh. So starting from nothing, first thing I want is some spawn. I'm going to do a spawn rate and spawn, I don't know, just have 5 a second for now, not too many. Get rid of the sprite renderer and replace it with the mesh renderer. And here I'm going to have my spiral mesh. This doesn't have the material set. Yes, it does. It's just compiling. There we are. And now we're getting our spiral things. So I want them, as we can see now, there's 5 spawning a second. If I show my particle count, you can see there's more than one, but we're only seeing one because they're all exactly on top of each other. So one thing I'm going to do, just lower that down a little bit. I'm just going to start with an initial random orientation. So mesh rotation, initial mesh orientation, and in this case I'm not going to use an orientation vector, I'm just going to do rotation, and I'm going to do a random unit vector, or random range vector, sorry, and I don't want it to be random in all axes, just in Z. And you can see now we're getting quite a cool effect, all of those different spirals working together. Now it's very random what's happening here, but there's also, my lifetime's really high, that's why I'm getting more and more. Put my lifetime down a bit, there we are. So they're going to spawn in, scroll up, but they're all sharing the same material. So this is a very common thing you get with animated materials. Definitely happens a lot more with meshes, but it also happens on sprites as well. So we're animating our material here rather than having just individual particles and animating those particles like we did with the leaf the other day. So we might want to create some randomness and some control of the material via the particle system, and we can do this. If I open up the material, we have a material node called dynamic parameter. Now we used the particle color node right back in one of the early videos in the series, and this was one way of getting information from Niagara. It's just getting the color information, so anywhere there's color, it's going to be getting that color information, passing it through to the material. Well, that's great, we can use it to colorize, and we can use it as an alpha to blend in and out, but we might also want to do other things. And so one of the things that that we can have is these things called dynamic parameters, and they're just parameters that we can name whatever we want, and then using our material in whatever way we like. And one thing that's been added with Niagara is now we can have lots and lots of these. So with Cascade we were always limited to 4, which wasn't really a limitation that often. You didn't use that many of them, and there were other ways around it, but you were limited to only 4 dynamic parameters. Now if we go to Niagara, we're going to be able to have more of these, which is a nice improvement. So what am I going to do with here? Well, I'm going to create a random value, and I want to just offset my start frame. So what we've actually got here is this panner. There's nothing plugged into it, but if we hover over, read the tooltip, defaults to game time if not specified. Well, that's effectively saying this is plugged into here. Here we go, eventually. And we just want to have a random value. So each mesh that spawns, we want to have a random start time. So all we're going to do is just add this dynamic parameter, and we'll be able to control this in Niagara, and create the effect that we want. So I'm just going to save and compile this, get this to be applied, and we'll see how we can break up this repetition in our spiral so they're not all sharing the same animation. So in this case it's something I'm only going to randomize once. I'm randomizing it on spawn. So on particle spawn, if I type in dynamic material parameters, create a node, and here we can see we can have up to 4 different sets of dynamic materials, dynamic material parameters, and we're just using index 0, which is the same as it says here, index 0. So it's picked up that name for me, and I'm not going to set anything else. I'm just going to set the random offset, and I'm going to use a random type, And in fact, we can use the same trick we used before. There's already a random value being generated, this material random here, and now you can see each one of those meshes is being kind of offset differently, and we're controlling that. We are getting some popping. There's some popping in and out happening. Well, let me just multiply this by particle alpha, and I can then fade them in and out. So particle color, I'm going to use the alpha value, compile that, give it a second. Yep, here we go. And now if I go into my particle, I'm going to do a particle update color, and I'm going to do color from float. So I want linear color from, not from float, from curve. Sorry, color from curve. I'm just going to have it fade in and fade out. There we are, just hidden that hard popping. Now the speed is being driven by the material. We could just change this here in the panel, or we could create parameters for this. But one thing we might want to do, rather than having just an initial random value, we might want to control the value directly over the course of the spirals animation. So here, I'm just going to go back to this set. Rather than using time, I'm just going to have a single value in here, and I'm going to call this manual. Let's try this. So now I'm going to control exactly where this wants to be. So I can preview it in here. And the value of 1 there is in the center. The value of 0 should also be in the center. 0.5 is going to be moving this up. So effectively what I'm trying to do is get my band to start at the bottom and then scroll up. So if I start at 0.5 and I end at 1.5, I would have scrolled that band all the way from the top to the bottom. So let's give that a go. So if I compile this, notice whatever the default values in here, they're just a preview for the material. We're going to be overwritten in here anyway. So now I've got my meshes fading in and out, and you can see that band stuck in the middle. But rather than writing the dynamic material parameter here at spawn, if I turn that off, I can do one at update. And this is now going to be updating every frame. So I'm just going to update manual offset, and I'm going to set this to be from curve. And now if I set these values correctly, if I start at 0.5, 0, 0.5, and I end at 1.5, you can see each one of these spirals that spawns. Put the spawn rate down a little. It spawns, goes up all the way up over the course of its life. So we can control that animation directly using an animation and controlling the material. I might just set this to be 0.6 and 1.4, so it doesn't quite get to tile and repeat. There we are. And so you can see we're spawning this, and it's scrolling out. But by getting these meshes already having such an interesting defined shape, we can do a lot of really complex motion. For example, if I just went in and set this to be all completely random, spawn rate, many, we can create really quite cool complex shapes and interesting things happening here. This could be like a tornado or stylized wind type effect, but it's all just based off a spiraling mesh and a simple scrolling material being controlled by a particle system. So that's it for today. Hopefully that's been interesting and informative. They are increasing levels of complexity. The more kind of little extra bits you add on, each bit combines with the other bit, and you get these huge kind of multifaceted ways of doing things. So you've got an interesting material that's doing something, we've got a mesh that's got some interesting shape, and we're using Niagara to create some complexity and randomness in there as well. And yeah, thanks for joining me. As always, if you have any questions, comments, etc., let me know. I will try and get back to everyone. Thank you to my Patreons for supporting the channel, and I will see you all next time.